Hello everyone. In today's video, we will study the anomalous behavior of water using the Hope's apparatus. As you have already learned, when any substance is heated, it expands, and when it's cooled, it contracts. On cooling any substance, the temperature reduces, the volume decreases, and the density increases. On cooling any substance, it loses its kinetic energy, due to which the motion between the molecule decreases. This decrease in the motion of the molecules stimulates the attraction between them, bringing them closer to each other. And with the result that the volume decreases and the density increases. But water behaves in a very different manner. It can be said that water has a very special quality or a very special behavior. This special behavior is called as the anomalous behavior of water. It is also known as the anomalous expansion of water. So what is anomalous expansion of water? Like any other liquid, when water is cooled, the temperature decreases and it starts contracting until it reaches a temperature when suddenly it starts expanding. Its volume increases and the density decreases. So how can it be defined? The anomalous expansion of water is increase in volume and decrease in density when it's cooled from 4 degrees Celsius to 0 degrees Celsius. You must be wondering why water behaves in such a way. To understand the concept, we have to look into the detail. Let's look into this graph. Let's understand this concept by studying the graph. First, we will look at graph A. The y-axis that you see here shows the volume of water, and the x-axis shows the temperature of water. Now look closely. At 10 degrees Celsius, the volume is 1000.20 centimeter cubes. At 9 degrees Celsius, it's 1000.15 centimeter cube. At 8 degrees Celsius, it's 1000.10 centimeter cube, and so on. By decreasing the temperature, the volume of the water decreases till it reaches 4 degrees Celsius. And as you can see, the volume starts going up again. Now let's look at graph B. The y-axis here shows the density of water and x-axis shows the temperature. And as it reads, by decreasing the temperature, the density goes up and it becomes maximum at 4 degrees Celsius. Now the question is, what's the reason for anomalous expansion of water? Ice, as you know, is less dense compared to water. It has a crystalline structure, which means it has a lot of space between the molecule, as you can see in the diagram, and so it is less dense compared to liquid water. If the temperature is increased, the ice starts melting. At 0 degrees Celsius, the water molecules loses its open structure. This results in lesser intramolecular distance between the water molecules due to the higher number of hydrogen bonds that are formed. Hence, the density increases from 0 degrees Celsius to 4 degrees Celsius, and that's why it's maximum at 4 degrees Celsius. Further rise in temperature results in increased intramolecular distance due to an increase in kinetic energy of the molecules. Thus, the volume increases and the density decreases. So what is Hope's apparatus? In 1805, a British physician and a scientist called Thomas Charles Hope devised a simple arrangement to find out or to study the anomalous behavior of water. This device was named as Hope's apparatus. This is Hope's apparatus. It is a metal cylinder which is open at one end and it's closed on the bottom. In the middle, the portion which you see, this is called trough. This trough is to keep the freezing mixture in there, which is usually salt and ice mixture. Now there are two holes, one on the top above the trough and one at the bottom. These are to hold these two thermometers which will go in here, and the center here in the cylinder we fill it with water. So let's look at the demonstration. I have these two thermometers. First I will insert it in the top hole and I'll call it T1. The second thermometer I'm inserting in the bottom hole and I'll call it T2. Alright. Now I have some water here. This water is at room temperature. You can already also check the temperature of the water. And it's approximately showing 27 degrees Celsius. So I'm going to fill this water in the cylinder. Okay, so it's pretty much full. Right now, as you can see, the water is at room temperature. Okay, so now I'm going to add the middle portion, that is the trough, with dry ice. Usually for this experiment, people use a mixture of salt and ice. The reason why I'm adding dry ice, I will explain it to you a little later. Try to predict what will happen to the water temperature. Will it be same or different in both the thermometers? Write down your prediction. While we are waiting for the temperature to go down, let's find out why freezing mixture of salt and ice is used. Well, the salt lowers the temperature at which water freezes. That is, it lowers its melting point. Water, as you know, freezes at 0 degrees Celsius. By adding salt, the temperature of the entire mixture drops. Depending on the kind of salt used, the temperature can be lowered up to minus 20 degrees Celsius. However, in Mumbai, we have a warmer climate. We have to use a stronger freezing substance to sustain the cooling effect. Therefore, we are using dry ice, which is solid carbon dioxide. Dry ice has a temperature of minus 80 degrees Celsius. This will help us to sustain the cooling effect as well as it will expedite the experiment. Okay, so let's come back to the question again. Yes, you guessed it right. The temperature in T2 will start decreasing. As you can see, it has already started going down and it will continue to do so until it reaches 4 degrees Celsius. Why did it behave this way? The water in the middle portion of the apparatus cooled down due to the freezing mixture in the trough, because of which the water contracted, the density increased, with the result it traveled down into the lower part of the cylinder. Therefore, the temperature in T2 decreased. Now, due to the water's anomalous behavior, it expanded. And due to this expansion, the density decreased and it rose up. The reading in the upper thermometer T1 has rapidly decreased, as you can see. But the temperature in the lower thermometer T2 is still constant. Hence, we can conclude that the density of water is maximum at 4 degrees Celsius. Water expands between 4 degree to 0 degrees Celsius when its density decreases. So, what are the takeaways from today's session? Most material expands on heating and contracts when cooled. When a substance is cooled, its temperature reduces, it contracts and occupies less space and the density increases. But water behaves differently. It has an exceptional property. The anomalous expansion of water is the increase in the volume and decrease in density when it is cooled from 4 degrees Celsius to 0 degrees Celsius. And we have verified this unique property of water using the Hope's apparatus. And now, here's an assignment for you. Think and answer. In the colder regions like Canada, Europe, US, The temperature reaches sub-zero levels in winter. The water in the lakes, ponds, and even the shorelines of river freezes. What do you think happens to the fishes and the other aquatic animals in winter? How do they survive in the frozen waters? Hope this video helped you to understand the concept better and it answered all your questions.